Hello and welcome to the next episode of my tutorial series on FM sound design using the Sonicware Liven XFM. So I received a couple of comments and questions asking for some clarification about how algorithms apply to FM sound design on the synthesizer and the meaning of the levels parameter. So I'm going to illustrate how algorithms do or do not apply and how what the XFM does maps to some other synthesizers. So I'm going to start by showing you the algorithm list that comes with the XFM. So while the XFM doesn't need to use algorithms, they are provided. I'll explain exactly what this diagram means. So in the context of an FM synthesizer, we have several operators. On the XFM, every operator is connected to every other operator and they can all modulate each other. Similarly, they can all output to the mixer. In the context of a lot of other FM synthesizers, each operator can either be a carrier, meaning it outputs to the mixer, or a modulator, meaning it is used to modulate another one of the sounds in the stack or another one of the operators in the stack. Rather than allowing you to control the send and receive levels of all of the operators, instead you have a single parameter known as level, which is simply how loud or quiet that operator is. In the context of a modulator, that level adjusts how strong the modulation is. In the context of a carrier, that adjusts how loud or how much of that signal goes to the mixer. So let's have a look at these operators here. The operators are numbered corresponding to the numbers of the algorithms available on the Liven XFM. The Liven XFM does not need to use algorithms. I want to reiterate that. This is simply a convenience factor or a way, if you're already familiar with other FM synthesizers, to connect the operators up in a certain way, but they are all always connected to one another. So I'll describe what one of them means. Note that the functions are left to right. So in other words, algorithm 1, the one in the far top left, operator 1 is a carrier. Operator 2 is a modulator, modulating operator 1. Operator 3 is a modulator, modulating operator 2. Operator 4 is a modulator operating operator 3. So hopefully that illustrates what this diagram means, and I can describe how you might decide what configuration is required for a particular sound that you're making. So the first decision that I would typically make is how many distinctly different sounds constitute the sound that you're making up. That's to say, imagine you wanted to play a chord of 4 notes. Well, if you wanted a 4-note chord to be your patch, then each of the operators should be audible separately. As a 4-operator synthesizer, there is only one configuration that can do that. In this case, it is configuration 12. All 4 operators are carriers. In other words, all 4 operators are outputting to the mixer. Let's imagine there were 3 components to the sound that I wanted. So we can see that that algorithm 7, 8, and 11 have 3 carriers in different configurations. So let's ask ourselves, why are those configurations different? Well, given that we're using 3 operators as carriers, there is only 1 operator remaining. That remaining operator is a modulator in this case, and it may modulate 1 of the carriers, 2 of the carriers, or all 3 of the carriers. So those are really the only 3 meaningful configurations. Imagine now that there are 2 components to the sound. If the sound has 2 components, there are multiple configurations of modulation. Number 4, in the top right-hand corner, we have 2 carriers, each modulated by 1 modulator. So I suppose the question you might be asking is, well, why do I need the modulators modulating the carrier, firstly? And secondly, why would I need modulators modulating another modulator? And that comes down to how FM sounds operate. Specifically, a carrier or a modulator, any operator, is simply a sine wave. In the Liven XFM, they also have a feedback path. That feedback path allows us to go from a sine wave type of sound to something which sounds a bit more like a saw wave, or something which sounds a bit more like a square wave. But what usually makes interesting timbres is not just modulating an operator with itself at the same pitch, therefore, but modulating it by something of a different pitch. This is what introduces the interesting harmonics. And those harmonics can be animated by enveloping that modulator. So looking at one of these algorithms, let's take one as an example. Algorithm number 3 on the top row, third across. Why might we choose that? Well, when an operator is modulated by another operator, we've heard that it introduces more harmonic content. When that modulator itself is modulated, that can produce even more harmonic content. So in the case of operator 3, we may choose to use the fourth operator, the one on the far right, as a sort of plucky transient sound, which will add complexity to operator 3, the first of the modulators in that algorithm. And that modulator in itself would adjust the timbre of the two carriers, which are audible. And those two carriers could each have their own envelope. So that might allow us to have, and they may also be modulated by different degrees. So that may allow us to have a sort of body tone and a transient tone. So I'm going to just pick one of these configurations. I think the simplest configuration is probably algorithm 4. So what I'm now going to do is switch over to the Liven XFM, and I'm going to load up algorithm 4, and we're going to use the level parameters that I described to make a sound in this way. So first let's turn the device on. As before, edit mode, let's open the first patch, let's initialize the patch. So this is just an init patch, but now what we're going to do is select an algorithm. So if I remember correctly, we wanted algorithm 4. Okay, so let's have a look at how it's set up at the moment. You can see operator 1, the mixer level is 127 because it's a carrier. Operator 2, the mixer level is 127 because it was supposed to be a carrier. Operator 3 and operator 4 do not output to the mixer. So what we have defined here are the two carriers. Now let's look at the modulation. Operator 1 has no feedback, no input from operator 2. It has a full level input from operator 3, no input from operator 4. So that is that one connection that was shown on that algorithm diagram. Operator 2, no input from 1, no feedback, no input from 3. It has input from 4. Operator 3, no input or feedback. Operator 4, no input or feedback. So let's jump back to that diagram. Algorithm 4, we can see operator 1 is a carrier modulated by operator 3. Operator 2 is a carrier modulated by operator 4. All very straightforward. Now, if we wanted to adjust those modulation levels, because we see that the receive levels here are 127, which is the maximum available receive level, we could adjust the receive level. But in this synthesizer, we have two ways of thinking about routings, which I'll try and describe now. We have the absolute volume of an operator, which is the output level of that operator, and that is what we call the level of the operator. Then we have the proportion of that volume that is received by other operators. This is a receive level. But not only is receive level used for modulation, the receive level is the level received by the mixer. So we could see, for example, if we're listening to operator 1, I'm going to turn operator 2 all the way down for now. We'll listen to operator 1. So at the moment, adjusting the mixer receive level is effectively just adjusting the volume in the way that you'd expect. We have that buzzy sound because it's being modulated by operator 3. We'll look at that shortly. But if I go to page 2 and I adjust this level, well, that's also adjusting the volume. Okay, so what this level is doing is adjusting the absolute volume of that operator. In other words, its output level. What the mixer level is adjusting its input level to the mixer. So full input level, but the output level is different. So one way, therefore, we can adjust the amount to which operator 1 is modulated by operator 3 is to adjust the level of operator 3. So operator 3 level is here. I'm going to play. We're only listening to operator 1. So you can see what I've done here is I've made operator 3 quieter. Even though it's not going to the mixer, in the modulation routing it's now quieter. So the timbre of operator 1 has changed. Operator 2, I'm going to turn it back up. Operator 1, I'm just going to mute to simplify things. So that's operator 2. Let's see. Operator 2 is turned up. And we know that operator 2 is modulated by operator 4. Again, we can adjust the receive level here, or we can choose to adjust the absolute level of operator 4. So now we know the algorithm. Now we've used the levels to make an adjustment. Let's experiment by adjusting the tuning. One of the things I find pretty convenient when designing these sounds is it's possible to mute an operator by selecting it and then clicking it. So presently, I actually only have operator 1 and operator 3 unmuted. If I mute a modulator, its effect is cancelled out. So operator 2 and 4 are muted. Okay, so what might I want to do to change the timbre here? Well, let's say I want to change the pitch of operator 3. So okay, so now operator 3 is 5 times the frequency of operator 1. So you could call that the fifth harmonic. And that is modulating operator 1. So let me do something similar to operator 2. So I'm going to mute operator 1, mute operator 3, unmute operator 2, unmute operator 4. So this is operator 2, and now I'm going to retune operator 3 to change the timbre. Okay, so let's unmute both of these. Okay, so I think that gives us something interesting to work with. Now I'm going to envelope the two modulators just to make them sound a little bit more interesting. I might give them a sort of attack and decay, and while those are being modulated, the timbral shift that I heard in operator 1 and in operator 2 will be varied in time. So I'm going to mute operator 2, 3, 4. This is just operator 1, unmodulated. Modulated by operator 3. So as I envelope operator 3, the sound of operator 1 will move between this and that. So I can choose how long-lived that tone is. So in this case, let me go for just the very straightforward plucked kind of sound. Longer than that. A bit short. So you can hear that as operator 3 animates, we've got something of a bell strike tone happening here. I'm going to do something similar to operator 2, and then we're going to play them in unison. So I'm going to turn off operator 1, turn off operator 3, turn on operator 2. So this is operator 2 playing alone. This is it when modulated. So in this case, I think I would like the modulation to be a bit more long-lived to give us a slightly different tone. So I'm going to go for the same type of shape, but I'm going to have the ratio of the lengths to be slightly different. So this I'll probably make quite a lot longer. Oops, unmute. Okay, so I'm going to unmute everything now. Okay, so I feel like I would like operator 1, the tone which has the shorter transient, to simply fade out over time. It can fade out over a relatively long period, so I'm going to do an envelope which looks like that. It can be long there, shorter there. Okay, I quite like that. Operator 2 is the one that we can still hear ringing out here. I might like its volume to drop a little bit more over time, so let's go to operator 2. Let's have it decay down to 50% level. Let's have it sustain at a very low level, 16 maybe. Let me shape the envelope quickly. This can be long. This can also be long. This can be shorter. Okay, quite nice. So I think we have a bit of a bell tone there. Because the algorithms here are not algorithms in the sense of arranging the operators and requiring certain connectivity, I can't really change the operator once I've made this sound. If I want to adjust how things are routed, I actually just have to adjust the mixer levels. If I make any operator have some mixer send level, you could say it's a carrier in function. If its mixer level is 0, but it's received by another operator, you could say that it is a modulator. But in general, in this engine, everything can always be a carrier and everything can always be an operator. One thing I might use the level for at this stage is to decide, is that timbral shift that I created too strong? If I decide that it is, let me listen to the effect of the two modulators. This is without either modulator. Let me bring in operator 4. Whoops, did I bring that in? No. So that's operator 4. Let's say I want a little bit more of that. So now I turn the level up, and now that impact is greater. If I was really designing this sound, I would probably say that would be a nice candidate for velocity sensitivity. So I might make it quite velocity sensitive. So that's on. Operator 3 is now off. So you can see operator 3 is that little quick transient that happens. I feel like maybe it's a little strong, so I'm going to turn operator 3 down a bit. That was at 5. So this is without it. So that's operator 3. And let's say that I want a bit of velocity sensitivity, a little bit less. So in this configuration, changing the levels of the carriers is equivalent to changing the receive levels on the mixer, as in the same effect can be achieved. One thing that's interesting with level is level defaults to 63, which is halfway through the spectrum. So you always have a capacity to turn the volume up or turn the volume down. typically the mixer receives, in an algorithm, they default to 127, which is the maximum. So you can actually only turn the volume down in that regard. So if I wanted one of these operators to be louder in the context of this sound, I could change it. So in this case, I didn't necessarily start out with a very clear picture of what I wanted, but I think you can see that I used quite a structured approach. I looked at the algorithms, I decided what the modulation was to look like. I started shaping my sounds by thinking about the timbres that I want first and listening. What happens if this modulator doesn't have an effect? Now let's listen if it does. Now let's create an envelope to shape that sound. So in this way, you can use these algorithms as a starting point, but generically on the synthesizer, it's not necessary to do that. Simply because if I decided, you know what, I would actually like operator 3 to also go to the mixer, and I'd like operator 4 to also go to the mixer. In fact, what if I only wanted those to go to the mixer? So at the moment they're quiet because the levels are low. But let's listen to this. So now, though operator 3 and 4 in my algorithm were modulators, they are now both modulators and carriers. Hopefully that's given a little more context on how the algorithms that are provided can be used and how the algorithms relate to the rest of the engine, and hopefully how this FM engine relates to other FM engines you may have been exposed to. In any case, thank you very much for watching, and I hope to see you all again.